Okay, good morning everybody. Welcome to chemistry class. Today we will study how to make electronic configuration of elements. To study about electronic configuration of element, we must know these three rules, that is FABU principle, Hund's rule and Pauli exclusion principle. We will read these three rules one by one. Okay, start with the FABU principle. What is FABU principle? According to FABU principle, in the ground state of an atom, electron fills in the lower energy level before occupying the higher energy level. What do you mean by this? Let's see it. These are the some levels of energy, like this is first level, this is second level, this is third level, this is fourth level. Okay, these are some energy level, and we know that in the first energy level we have 1s, second energy level we have 2s, 2p, in third energy level we have 3s, 3p, 3d, in fourth energy level we have 4s, 4p, 4d, 4f, like that. We will study it later in this class only. So in the first energy level, firstly we have 1s. ठीक है, फर्स्ट एनर्जी लेवल में हमारे पास क्या है 1s. So that's why when this 1s is completely filled, then electron will fill in the 2s and 2p. When this 2s and 2p is completely filled, then electron goes to the third level, then fourth level, then fifth level. This is simply known as FABU principle. Now let's see it more clearly. After FABU principle, we will study about Hund's rule and then Pauli exclusion principle. After that, we are able to make this electronic configuration. Okay, so let's firstly move to the FABU principle. What is the basic mean of this FABU principle? So we have to make one table. See, this is very easy. Firstly, we will start with 1s because the first energy level is 1s. After that, we will draw 2s, 2p, because in the second energy level we have these two orbital 2s and 2p. Then in the third energy level we have 3s, 3p and 3d. In in the quantum number, you already studied that there are 4 subshells are there, and their name is S, P, D and F. These are the 4 subshells you must read in the quantum numbers. Okay, in S there is 2 electrons, in P there are 6 electrons, in D there are 10 electrons, and in F there are 14 electrons. Okay, these are the number of electrons in these alternative subshells. So in the fourth energy level we have 4s, 4p, 4d and 4f, like that. In the fifth energy level we have 5s, 5p, 5d, 5f. Okay, now come to the sixth energy level, 6s, 6p, 6d, so on. ऐसे करके आप इसको चलाते रहेंगे. 6f, now 7s, 7p, 7d and so on. Okay, this is very easy. Everybody can draw it. बहुत आसानी से इसको कोई बच्चा बना देगा. Now how we have to cut it? अब कैसे इसको काटना है? That is the major thing which you must know. Firstly, take 1 1 in first 2 step. Okay, what I am saying, 1 1 in first 2 step, then 2 2 in next step, then 3 3 in next 2 step, and then 4 4 in next steps. Okay, but till 7s you will find maximum number of elements is completed up till 7s, that is 7th energy level. Okay, now what we have to do, we have to start from 1s and go there to the upward direction, like that. We have to draw it like that. What this arrow shows, that we have to travel from 1s to 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 6d, 5p, 6s, 4f, 5d, 6p and then 7s. Like that we have to travel. Okay, इस प्रकार से हमें क्या करना है, इसमें चलते चले जाना है. Now how we can make the now electronic configuration? अब now most important question is how we can make the electronic configuration. We will make the electronic configuration with the help of this series. Okay, how? Let's see. For example, we have to make the electronic configuration of sodium. We must know the atomic number of sodium, that is 11. You all know it, na? The atomic number of sodium is 11. So let's start from there. Firstly, we have 1s, and how many electrons are there in s? 2 electrons. So first is 1s2. Now after 1s we find 2s. So how many electrons are there in 2s? 2. Not 2s, this is s. Okay, 2 represent here the energy level. This s is from the first energy level, this s is from the second energy level. After 2s we get 2p. And how many maximum number of electrons can occur in the p orbital? P subshell is 6. So we write here 6. Now you must see that how many electrons are completed there in our electronic configuration, how many we required. So there are 6 plus 2, 8 plus 2, 10 electrons is completed till now, and we required only 1. So in the next energy level, that is 3s, the number of electron can be represented in s are 2, but we required only 1. So we will write here 1. Now the number of electrons in Na is 11, and here in our electronic configuration 11 electrons are completed right now, because we can sum up from there. 2 plus 2 4 plus 6 10 and 1 11. So like that you can easily make the electronic configuration of sodium. Okay, take another example, like we want to make the electronic configuration of iron, that is 26. Okay, I am saying again and again that you must know the atomic number of every element till 30. Okay, minimum till 30. So let's start as we do earlier. Firstly, there is 1s2, then 2s2, then 2p6, then 3s2. Okay, well done from till 3s till now. 1s, 2s, 2p, 3s. Okay, after 3s there is 3p. Now 3p 6. After 3p we have 4s, 4s2. Okay, now firstly count the number of electrons till 4s. That is 10, 12, 12 plus 6 18 plus 2 20. Till 4s we have 20 electrons. Now we required only 6 electrons, and after 4s we have 3d. So 3d, d subshell can have 10 electrons, but we required only 6 electrons, so we will write here 6. Now you can count the total number of electrons. These are equal to 26, and this is the required electronic configuration of iron. So like this you can easily make the electronic configuration of any element. Okay, there are some exceptional case also in the d orbital, which we will study later on in this video or in the other video. Let's see now Hund's rule and Pauli exclusion principle before doing some exceptional case. Okay, so let's see it. I think now you are able to make the electronic configuration of every element, and if you are not able to make the electronic configuration of any of the element, then you can drop your comment also in the inbox. Okay, now let's see Hund's rule. What is Hund's rule now? According to Hund's rule, we can say that the pairing of electron cannot occur until one electron is occupied by every orbital. ठीक है, this is the Hund's rule. What is this? They are saying that pairing of electron cannot occur until one electron is occupied by every orbital. What do you mean by this? Let's see it by taking an example of sodium, which the electronic configuration we made just before some time. 1s2, 2s2, 2p6, 3s1. This is the electronic configuration for sodium. Okay, so these are the number of electrons which I just tell you. You will get these information from the quantum number, the topic before these all three rules in the second unit. Now there are number of orbitals also there. Okay, there are number of orbitals are also there for s the number of orbital is 1. For P, the number of orbital is 3. For D, the number of orbital are 5, and for F, the number of orbital are 7. So about these things, they are saying that the number of orbitals can be something. So let's see it. If we take an example of S, so in S there are 1 orbital. In the P, the example is 3. In the D, we can take 5 like that, and in the F we have 7 orbitals. Okay, this is S, this is P, this is D, and this is F. And there in S there is 1 orbital, in the P there are 3 orbital, in the D there are 5 orbital, and in the F there are 7 orbitals. Okay, now if we name this, then P orbital have 3 names. You will see it further: Px, Py, Pz. These are the name of these 3 orbitals of P. And if we take an example of D, then the name are dxy, dyz, dzx, dx square minus y square, and dz square. These are the name of D orbital. Okay, so don't worry about that. After doing some of the questions, then these all things will be learned to you. Now, Hund's rule: pairing of electron cannot occur until 1 electron is occupied by every orbital. That means that pairing जो है वो नहीं हो सकती जब तक 1 electron is occupied by each orbital. So we are taking an example of this, like if we draw 2p and 3s, we have to draw the last 2 orbitals only. Okay, so in the P there are 3 orbital, in the S there is 1 orbital. So P 1 2 3, now 4 5 6, and here 1. So what we have done in the P, that we firstly fill 1 orbital in each 1 electron in each orbital. Then after I am pairing up its in the twice form, that is 4th, 5th, and 6th. So this is the Hund's rule. Okay, we will take one more example there. Okay, so that you can learn it in very easy way manner. Like we just wrote the electronic configuration of iron, and the electronic configuration is 3d6 4s2. This is the electronic configuration of iron. We just do it just now, earlier one. So in the d orbital we have 5 orbitals, and in the s there are 1. This is 3d and this is 4s. In the d orbital there are 6 electrons. So according to Hund's rule, firstly we have to fill 1 electron in the each orbital, because there are 6 electrons in the d. So 1 2 3 4 5 6 electrons are filled, 5 electrons are filled, only 1 is left, and we have to fill this 1 in the first, because they are saying that pairing of electron cannot occur until 1 electron is occupied by every orbital. जब तक कि हर एक orbital के अंदर 1 electrons ना आ जाएं, till then we can't pair the orbital. And here 2 electrons are there, so we will write 2. I think now Hund's rule is clear to all of you, that pairing of orbitals cannot occur until 1 electrons is occupied by each orbital. After 1 electron is occupied, then we will start pairing from the first, like we have done in the case of iron. Now the last one. The last is Pauli exclusion principle, and we will explain it by taking the same example of iron. According to Pauli exclusion principle, there are 2 things which Pauli exclusion principle said. First is every orbital can only have 2 electrons. This is the first thing, first rule for Pauli exclusion principle, that every orbital can only have 2 electrons. Like we can say here in the d orbital first, that is dxy, contain only 2 electrons, then nothing is left in the d, so that's why they contain only 1 electron. But here also it contain only 2. That means that maximum any orbital can have 2 electrons. Okay, that is the Pauli exclusion principle. And one more thing that Pauli exclusion principle is saying, that the 2 electrons in an orbital must have opposite spin. Okay, this is the second thing or principle for the Pauli exclusion principle, that the 2 electrons in any orbital, किसी भी orbital के अंदर जो 2 electrons है, they must have the opposite spin. उनकी spin कैसी होनी चाहिए? Opposite. If one is clockwise, then second is anti-clockwise. If first is clockwise, then second must be एंटी क्लॉकवाइज. जो सेकंड होगा वो क्या होगा? एंटी क्लॉकवाइज होगा. दैट इज द these 3 rules are saying. A FABU principle set the basic give us the basic formation for the electronic configuration. Hund's rule tells us about the filling of electron in the orbital, and Pauli exclusion principle set the number of orbital and their orientation in an orbital. So I think now you all know how to make the electronic configuration of elements. There are some exceptional case also, students, in the d orbital, which we will study in the next class. Okay, so thank you for watching.